Up till now we've been talking about angles that can be measured in degrees, and now we're going to be looking at radian measures of angles. Radian measures of angles are preferred for more of the theoretical work in mathematics, such as when you take your calculus courses after trig. And the reason that we like to work in radian measure in those upper level math courses is the domain for the trig functions are real numbers rather than angles. So let's go ahead and define what a radian is. We'll show a picture of that, and then I also have a visual aid to help with defining what a radian is. Now, the technical definition of radian is given right here. It's an angle with its vertex at the center of a circle. So we could start drawing this as we're describing it. So it's an angle with its vertex at the center of a circle. So we can go ahead and sketch in a circle here. Now, if it's an angle with its vertex at the center of a circle, the initial side we'll call the x-axis. So an angle with its vertex at the center of the circle, that's at the origin, that intercepts an arc on the circle equal in length to the radius of the circle, and it has a measure of 1 radian. So the radius of the circle is the distance from the center to any point on the circle, and I'll just use this point right here. Well, if we take this line segment R and we, let's say, move it up here and we wrap it around, the distance from here to here and the distance from here to here is the same, and we're going to call that a radius. And so what happens here, this is the angle theta, and it's equal to 1 radian. So that's the definition of a radian. Now, it doesn't matter what the radius is. This will hold if the radius is 1 or 10 or 20. This is the definition of 1 radian. Now, it's kind of hard to visualize this sometimes, so I have a little bit of a graphic that will help us do that. So for this graphic, we have our center, we draw our circle, the red line is the radius, then I take this radius and I go ahead and wrap it around from this point all the way up, and I make this arc, and when I intersect the arc with that midpoint, that's 1 radian. Now I can look at multiples of 1 radian. 2 radians would put us in quadrant 2, 3 radians is still in quadrant 2, and of course we know pi is 3.14159, so that's 180 degrees right here is pi radians. And of course this is half a circle, so if we double that, that would give us 2 pi radians. So that's an example of defining what a radian is and what that looks like. Now let's go ahead and look at those multiples of radians that we were just looking at. So if we talk about 1 radian and we talk about spinning around the unit circle, we've already decided that this is 1 radian, and you don't have to put the word radian with it each time. Something to note here is that radians do not have a unit, or radians are not a unit of measure like feet or inches. Okay, so you don't have to put the word radians. It's understood to be radians, and I'll show you what that means here in a little bit. So if we take that same multiple, this would be 2 radians. Here would be 3 radians. It's very, very close to the horizontal axis. And then right here is 3.14 radians, which is really pi radians. So I'll put in pi radians here. And then if I keep spinning around that unit circle, 4 radians, 5 radians, 6 radians, and then this little bit that's left over would give me 6.28 or 2 pi radians for a full spin around the unit circle. And of course, if we never move at all, that would be 0 radians. Okay, so I could move in the positive or the negative direction. So this value here of 5 radians, if I rotate it in the negative direction, that would be a negative 1 radian. Okay, so these are some examples of what we're looking for with radians. And again, radian is not a unit of measure like a foot or an inch or centimeters or anything like that. Now what we want to be able to do is to convert between degrees and radians pretty fluently. So at first it's going to take some effort to think about how this is happening, but pretty soon you'll be able to just think in your head, oh, pi over 6 radians is the same as 30 degrees. It'll be kind of a natural conversion. And you want to make sure you have all those memorized because it's going to be very important. So let's go ahead and look at converting between degrees and radians. Now when we convert between degrees and radians, it's really pretty simple once we have it set up correctly. So for instance, what we know already, we already just looked at how 180 degrees was equal to pi radians. I'm going to use rads for radians here. So remember when we spun around for pi radians, that was the same as 180 degrees. Well, at this point, if we go ahead and divide both sides through by 180, what I get here, 180 divided by 180 is 1. So 1 degree is equal to pi over 180 radians. And this is really the conversion factor that we want, pi over 180 or 180 over pi. And the reason I could get that is if I took the same 180 degrees equals pi radians, instead of dividing through by 180, we could divide through by pi, and I'd be left with 1 radian equals 180 degrees over pi. So these are my conversion factors. So it's either pi over 180 or 180 over pi. And I'll show you a quick and easy way to distinguish between which one I should use when. So let's look at converting degrees to radians. And a lot of times you're going to have to use your calculators for this, but there's some standard angles like the 30, 45, 60, 90, 270, all those quadrantial and all those special or standard angles and their multiples you should have memorized. So to convert from degrees to radians, we multiply by pi over 180. And I'll show you why that is. So you really don't have to memorize this. It'll make sense once you see why we choose to do this. So if we had something like 60 degrees, let's think about this. What do I have to do to get this thing to cancel? Well, think about conversion. When you're using unit conversions, I want the degrees to cancel and I want to be left with radians. So the degrees are going to have to go on the bottom and the radians will go on the top. So that's why I'd use pi over 180 here. And so that's for this example, this pi over 180. So once I look at this, I have 60 pi over 180. I can cancel the degrees if you want to think about that. 60 goes into 180 3 times and I'm left with pi over 3. So this means that 60 degrees is equal to the measure of pi over 3. So they are the same angle, they're the same amount of rotation. Let's go ahead and look at another one. Let's look at 45 degrees. So again, these are those special angles that we've talked about before. We want the degrees to cancel, so I'll put degrees on the bottom. Pi goes on top, and I'm left with 45 times pi over 180. 45 goes into 180 4 times, and I'm left with pi over 4. So 45 degrees equals pi over 4. And again, we want to have these memorized. It's a good thing to be able to convert them, of course, but at some point we'll want to commit these to memory. We can also move in the negative direction, negative 150 degrees. We want degrees to cancel, so we'll put our degrees on the bottom. And here I'll be left with 150 pi over 180. And again, the degrees, you can think about them as canceling in terms of units. And I'm left with 150 over 180 pi. Now, if you want to plug this into your calculator, you can to multiply these out, and you're going to get a decimal. But these pi over 3 and the pi over 4 are called exact form, meaning they're multiples of pi. So we want to leave the pi there. On your My Math Lab, if it says, convert and round to 4 decimals, then you'd actually plug the pi in. But here we have 150 over 180. And, oh, this was a negative, so let's not forget that. And if I think about canceling, 30 goes into 150 5 times, so this would be a negative 5 pi. And then 30 goes into 186 times, so I'd be left with negative 5 pi over 6. Okay, so negative 150 degrees, make sure you get that negative in there, is negative 5 pi over 6. Okay, so that's converting from degrees to radians. And you'll have a lot of questions in My Math Lab that you'll be converting. And again, if it says exact form, it means it wants a pi in the answer. If it asks you to convert to decimals, then you can go ahead and plug negative 5 times and use the pi button on your calculator. Just don't use 3.14 and then divide that by 6. Now the next thing we want to do is we want to convert from radians to degrees. Now when we convert from radians to degrees, we're going to do just the opposite. Now remember the last one we did, we multiplied by pi over 180. This one will multiply by 180 degrees over pi. And again, it's going to make sense why we choose this ratio over the other one. So let's go ahead and look at an example. Let's look at 5 pi over 4. Now, you don't see a degree here, so if you don't see a degree, that's implying that this is in terms of radians. So if it said 5 pi over 4 degrees, that would be a degree measurement that we could convert to a decimal to get an idea of where that was. But because there's no degree, that's assumed to be radians. Now, it's easy for me to remember. I want the pi's to go away, so pi's have to be on the bottom. That leaves 180 on the top. So I'm left with 5 times pi times 180 degrees over 4 times pi. Now, pi's will cancel here, and then 4 goes into 180. If we divide 180 by 4, we get 45, so this would be 45 degrees. And then 45 degrees times 5 would put us at 45, 90, 180, would look at 225 degrees. So what we have here then is 5 pi over 4 is 225 degrees. Okay, let's look at another one, 4.25. Now, you don't see a degree here, so it has to be in radians, and if we want to convert it to radians, then I'm going to multiply it by 180 degrees over pi. So this would be 4.25 times 180 degrees over pi. So when you plug and chug this into your calculator, you're going to get a decimal, 243 point, and I'll go ahead and write this out, 5070629. This is now degrees because of this degree mark right here. And then, of course, we can convert this to degrees and minutes. So we'd have 243 degrees plus 0.5070629 times 60 minutes. So plugging that in and multiplying it would be 243 degrees and 30 minutes. And there's a little bit of a decimal there, but it rounds to 30 minutes. So that would be an example of rounding to the nearest minute. Let's look at another one. Let's look at 7 pi over 6. Now there's no degree here, so that means this is a radian. I want to convert this to degrees, so I have to be left with degrees on the top, and I want the pi's to cancel. So here, I'm going to, I don't like to cancel my original problem, so I'm going to write this as 7 times pi times 180 degrees over 6 times pi. So the pi's cancel. 6 goes into 180 30 degrees or 30 times, and 7 times 30 degrees is 210 degrees. So this would mean that 7 pi over 6 is equal to 210 degrees. Okay? And again, eventually you're going to have these memorized, but for now that's how you convert them. And again, exact form means that you're going to have a pi involved somewhere. And here, for exact form, I just get a nice 225. There's no rounding or anything else going on here. Now in the second one, 4.25 times 180 over pi, there was rounding involved. If it asked me to leave this in exact form, I'd probably have to leave it just like this because I really can't do much else with it. Okay, so let's go ahead and remember that if there's no unit marked, if it doesn't say degree, it means radians. And it's really important that you know the difference between whether your problem is working with degrees or radians. Okay, so let's grab our calculator. We've worked with the calculator before. A couple things that we want to remember here. At the top of the calculator it says degree. So if you're working a problem in degrees, make sure it says degrees here. If you want to switch this, you go to mode and you arrow down, and here you'll see radian is flashing, and hit enter, and now radian is selected, and you'll see that we're in radian mode up here. So before you ever work on a problem, make sure that you're in the correct degree or radian mode. Okay, and if you're not, go ahead and switch it back. Now, we haven't worked any of my math lab problems yet, and we will in a second, but first of all I want to show you what we're going to call the unit circle. Now unit circle means basically that we have a circle with a radius of 1. So I'm going to paste in a nice perfect circle so we don't have one that's lopsided. Okay, so here's an example of a nice circle on the Cartesian coordinate system. So this is my x-axis moving horizontal, and y is my vertical axis. Well, if we know if we split this quadrant in half, the full quadrant is 90 degrees. So if I go to this point on the circle, I've split 90 in half, and half of 90 is 45. So this is a 45-degree angle, and 45-degree angle is equal to pi over 4. Now every multiple of 45 will have a pi over 4 in the denominator. And again, if you want to look at how we convert that, then we would take 45 degrees, let's kind of come up here, and this is where we converted 45 degrees, and we got a multiplication by pi over 180, and we got pi over 4. Okay, so that's how I'm converting each one of these. I'm taking the degree measurement times pi over 180. Now, you might think this is going to be hard to memorize this whole circle, but really it's not too bad, because I know if I bisect in this direction, I'm also cutting this quadrant in half. So this will also be some multiple of pi over 4. Now let's think. If we double 45, that's going to put us up here at 90 degrees. And if we add another 45, that'll bisect this quadrant. 90 plus 45 is 135 degrees. And then that will bring us to 180. 135 plus 45 is 180 degrees. 180 plus 45 is going to be 225. 225 plus 45 is 270. And then of course this bisects as well. So 270 plus 45 would put us at 315 degrees. 315 plus 45 would put us at 360 degrees. And of course if we didn't do anything at all, we'd be right here at 0. So if we think about it as splitting these in half, and we look at multiples of pi over 4, this would be 1 pi over 4, this would be 2 pi over 4, because it's 2 45s, or 2 pi over 4s, and that reduces to pi over 2. Okay, so here's 1 pi over 4, 2 pi over 4, this would be a 3 pi over 4, and again you can get that by taking 135 times pi over 180. This would be 4 pi over 4, and of course the 4's cancel, I'm just left with pi here, so 180 degrees is equal to pi. This is equal to 5 pi over 4. This would be 6 pi over 4, because again it's 6 multiples of pi over 4, so this is 3 pi over 2 if I reduce it. This is 7 pi over 4, and then this is 8 pi over 4, and of course 8 pi over 4 reduces to 2 pi. So if we think about it as bisecting quadrants and looking at multiples of pi over 4, it's really not too bad. So that's for 45 degrees. Let's go ahead and look at 30 degrees next. So if I look at a 30 degree angle, that's clearly less than a 45. We'll use a red line for that. This is equal to 30 degrees. Now 30 degrees, I don't know if we did a 30 degree conversion. Let's look up here. We didn't do a 30 degree conversion, so let's stick that in. 30 degrees times pi over 180. The degrees cancel. 30 goes into 180 6 times, so I'm left with pi over 6. So this means that 30 degrees is equal to pi over 6. So every multiple of 30 is a multiple of pi over 6 then. So this 30 degrees is equal to pi over 6. The next multiple of 30, 30 plus 30 would be 60. So this would be 60 degrees, and this would be 2 pi over 6, which is pi over 3 if I reduce it. Now this 60 degrees is a special multiple, and I'll show you what I mean by that. Multiples of 60, like 60, 120, 180, etc., are going to have a little bit different characteristic because I don't have that denominator of 6, I have that denominator of 3. So I really should change these to a little bit different color. Let's change those to green, just to distinguish them between, it is a multiple of pi over 6, but it's kind of its own special multiple. Okay, so next let's go ahead and look at the next multiple of 30 degrees. So 30, 60, 90 would be that multiple. Now remember, 90 was already a multiple of 45 as well, so it's several different multiples. So this is 1 pi over 6, 2 pi over 6. This would be the same as 3 pi over 6, which reduces to pi over 2. So again, we get that pi over 2 just like we did here. Multiple of 90 plus 30 then would be 120. So this would be 120 degrees. This was 3 pi over 6, so this would be 4 pi over 6, which reduces to 2 pi over 3. So again, multiple of 30. The next multiple of 30 would be at 150 degrees. Put that down in here. So that would be 150 degrees, and this would be 5 pi over 6. Okay, so again, 1 pi over 6, 2 pi over 6 reduces to pi over 3, 3 pi over 6 reduces to pi over 2, and you can kind of follow that same thing from here. Well, another multiple of 30, 150 plus 30 would be 180. So I hit this again. I hit it with the 90, or sorry, with the 45, and now I'm hitting it with the 30. So this would be 6 pi over 6. The 6 cancels, and I'm left with pi again. So 180 is equal to pi radians. Next multiple here, after 180, would be 210. So this would be 210 degrees. This would be 7 pi over 6, because I was just at 6 pi over 6. And you notice this 30, okay, as we're kind of keeping track here, these are starting to reflect into the different quadrants. So my next multiple of 210, 210 plus 30 would be 240. Let's scroll down a little bit. And this would be 8 pi over 6. Now 8 pi over 6 would reduce to 4 pi over 3. Next multiple, 240 plus 30 would be 270. So this would be 9 pi over 6. So that's our next multiples right here. And of course 9 pi over 6 reduces to 3 pi over 2. So remember, the 6 pi over 4 up here was because it was a multiple of 45, but now I'm looking at multiples of 30. Next multiple would be 300. 270 plus 30 is 300. So this would be, we were at 9 pi over 6. Now we're at 10 pi over 6, which reduces to 5 pi over 3. 300 plus 30 would be 330. So this would be 11 pi over 6. Because again, 10 pi over 6 plus another multiple of pi over 6 would be at 11 pi over 6. And then 330 plus 30 would leave us at 360, which is 12 pi over 6, which reduces to 2 pi. Okay, so if you just keep thinking about how it reflects and the multiples, these are pretty easy to figure out as long as you kind of keep track of those multiples. Now let's go up to this other special case, this 60. Now everything that is a multiple of 60 is also a multiple of 30. So let's see where we run into that. Here's 60. 60 degrees converted to radians is pi over 3. 60 plus 60 is 120. So this is not only a multiple of 60, it's a multiple of 30 as well. But it reduces, so that's why we get our 2 pi over 3 here. So anything with a something pi over 3 is a multiple of 60. It's also a multiple of 30, but it's the larger number that goes into that would be a multiple of 60. Our next one would be 120 plus 60 would be this 180. So that would be 3 pi over 3, which reduces to pi as well. Next multiple, 180 plus 60 would be this 240. So that would be right here. And here's that 4 pi over 3. 240 plus 60 is going to bring us right here to 300. And of course that converts to 5 pi over 3 radians. 300 plus 60 brings us right back here to 360 degrees. So being able to fill out this circle will be really important. I'm sure it'll show up on handwritten homework and exams. So basically you need to know all of these nice little standard angles and the quadrantial angles and the relationship between the degrees and the radians. Now everything so far has been in movement in the positive direction. I could also move in the negative direction, and let's say I could go negative 30 degrees and then start talking about that would be a negative pi over 6. So it makes a difference whether we're moving in the positive or the negative direction, and you just always have to be really clear about that. Let's go ahead and look at some examples where we are finding the function values, the trig function values in radian mode. Now to get started with this, on our first attempts, what we're going to do is we're going to convert everything to degrees, and then we're going to find what the trig function is. But pretty soon I want you to be able to work enough of these and think about these and be able to work in radian mode without converting. Okay, so let's go ahead and look at finding trig function values in radian mode. So to get started, we are going to convert to degrees, but I don't want us to do that very long. I want us to start to be able to think radians and equivalency to degrees, and then be able to find those trig functions. Because remember, you should have the sine and the cosine and the tangent, etc., memorized for those nice standard angles and quadrantial angles, and we need to be able to think about those in radian mode as well. So let's start with the sine of 3 pi over 2. Well, if I convert this, this would be 3 pi over 2 times 180 over pi. So this is the sine of 3 times pi times 180 over 2 times pi. Now if I simplify this, the pi's will cancel, 2 goes into 180, I'll show how that works here. The pi's cancel, the 2 goes into 180 90 times, and 90 times 3 is 270 degrees. And the sine of 270, and again this is something that you just have memorized, is -1. Now where does that come from? If you don't recall from our unit circle that we've been talking about, 270 degrees is this angle right here. So this is 270 degrees. And if we think about this, if it's a unit circle, it has a radius of 1. This is the ordered pair 0, -1. And this would be the cosine, and this would be the sine, because this is the unit circle. If it wasn't the unit circle, I could not say this, but because it's the unit circle, I can go right after the cosine and the sine. And again, it's something you just simply have to have memorized. Now pretty soon I want you to start thinking 3 pi over 2 and 270 are synonymous, so you don't need to convert these every time. You just start to think that they're equivalent. And it takes a lot of practice, and you have to work a lot of these problems. And again, you simply need to commit these to memory. So say the cosine of 5 pi over 6. Well, we want to convert this to degrees. So when I convert to degrees, I want the pi's to cancel, and I want 180 degrees on the top. The pi's cancel. 6 goes into 180 30 times. 6 times 30 is 180. And I'm left with 5 times 30 is 150 degrees here. Okay, so 150 degrees. How did we find the cosine of 150 degrees? Well, what we do is we graph that cosine of 150 degrees. And if you want to think about the unit circle, you can. Or if you think about 150 degrees, I could find its reference angle. And the reference angle is right here, is 30 degrees. So first of all, 150 degrees is in quadrant 2, and it has a reference angle of 30 degrees. So in quadrant 2, cosine is negative. So this is going to be negative cosine of 30 degrees basically. That's what I can come up with. So I need to drag that negative along, and again I just simply have this memorized. The cosine of 30 degrees then, again I find that from the reference angle, is square root of 3 over 2. So the cosine of 5 pi over 6 is negative square root of 3 over 2. And again, as soon as I start seeing this 6 on the bottom, you're going to start thinking, that's a multiple of 30 degrees. And 30 times 5 up here is 150. It's kind of a quick jump here. Anytime you see a 3 in the denominator, it's a multiple of 60. And anytime you see a 4 in the denominator of a radian, it's a multiple of 45. So those are some kind of quick tips to keep in mind and some hints to keep in mind. As usual, if you have questions, make sure you just shoot me a text. I'm happy to help. If you want to write out the unit circle that we have up here with all the degrees and radians on, that would be a good idea. You want to practice this so you could fill this in automatically with all the degree measurements and all the radians that are equivalent. This is the type of thing that you're going to see again on your handwritten homework and on an exam. And again, it just simply needs to be memorized. We'll be adding to this a little bit because we're going to add the sine and cosine to this table pretty soon as well. So if we can just start with this and start memorizing degrees and radians first, that'll be a nice start. On this section, good luck, and please let me know if you have any questions.